Welcome, everybody. Thank you for joining us today. This is the third in our series of 8 EHS webinars. We appreciate you being here today. Our topic today is going to be industrial hygiene matters. And I'm joined today by my colleague, Joe Hoffman, who's a certified industrial hygienist and one of our senior project managers who does a substantial amount of industrial hygiene work, and he's going to be leading our session today. The session is an hour. If you have questions, I would kindly ask that you use the Q&A function at the bottom of your screen, and at the end of the presentation, we'll go through the questions. And for some reason, if we run out of time to answer questions, we'll still email the all responses to those unanswered questions. Thanks again very much. And Joe, I'm going to turn it over to you.
All right. Good afternoon. Good morning, everyone. We sincerely appreciate everyone taking the time to be with us today. I hope as we go through today's presentation, you learn something or are able to take something back to your workplace or your coworkers. But anyway, I just wanted to tell everyone that we appreciate it, and we look forward to hearing your questions and comments. So if I can share my screen. All right. So like Leo said, we're going to be discussing industrial hygiene matters, strategies for assessing exposures to hazardous substances. Just a brief outline of what we're going to be discussing today. The goal is to provide some insight and assistance in developing an IH sampling strategy. So we'll discuss what does a model IH plan look like, identifying when we need to sample, evaluating the potential and severity of those exposures, how do we control those exposures, and then kind of putting it all together into a classic written type program, an IH program that we can use to manage those hazards for our employees. So this is a model of an IH plan. It's very simple. You really should approach industrial hygiene issues like any other health or safety hazard at the workplace. Identify what needs you have, evaluate the risk posed to employees from those hazards, and then control those exposures. So industrial hygiene is really no different. So if we go in with that same thought process, we can really do some positive things to help protect our workers. So the first step is to identify when do we need to do an industrial hygiene or an IH assessment. When are those things necessary? So there's several options or several reasons why we would need to. Whether that's OSHA compliance, evaluating how good our emergency response is, building an employee exposure database, addressing an employee concern. There's numerous reasons why we would need to or want to sample. So we'll take a look at some of these in detail. The first few here that we're going to discuss are regulatorily driven. So these are the have-tos, right? These are the reasons that we have to sample. We can't get out of it because OSHA says that we must sample. So this first one here is 1910-1000. So this is really our most basic requirement. It's a list of substances commonly referred to as tables Z1, Z2, and Z3. Within those tables, we've got a laundry list of chemicals and then an associated exposure limit. OSHA says that we have to sample to verify that our employees are not exceeding those limits. They don't give a whole lot of other guidance on what else we have to do. They just say that it's our job to ensure that we make sure that their exposures are below any applicable limits. We also have some specific or chemical specific standards. For some chemicals, based on the severity of their health effects, we have additional requirements when it comes to our employees who are exposed to those specific chemicals. These additional requirements may include frequency of monitoring, written programs, medical surveillance, regulated areas, employee notification, and so on. but because of the health effects of these specific chemicals in 1910, 1001 to 1096, we have to sample at a specific frequency to evaluate whether or not they are being exposed greater than the permissible exposure limit or the action level. And then based on those results, some of those other requirements kick in. We also have noise to consider. So there's a standard specific to occupational noise. The noise standard offers several ways to evaluate exposures, but ultimately all of them lead us to the same result of we have to collect data, or we have to monitor employees, or we have to evaluate the areas of high noise to make sure that we're not overexposing our employees. It's just like air contaminants. We have to control those exposures, and the only way to make sure that we are is by getting that information and that data. We also have a respiratory protection standard. So the respiratory protection standard states the employer shall provide respirators which are applicable and suitable for the purpose intended. So they don't specifically say you have to collect a sample, but without any industrial hygiene data, we have to, it'd be very difficult to ensure that our full face respirator or air purifying respirator is adequate for the exposures that we're seeing. So we have to use that data to drive whether or not we're using the appropriate level of respiratory protection, whether or not we have the right cartridge selected, etc. Hazard communication standard. So I'd be lying if I told you that the HazCom standard tells you that you have to sample, which it doesn't. But what it does require is that employees educate employees on the chemical hazards they face. So from an EHS professional standpoint, if our job is to make sure we're doing the best we can to educate our employees, how can we do that without having some industrial hygiene information or data to back up that HazCom training that we provide them on a regular basis? So IH sampling and IH data is a great tool. It will help us educate those employees so that they truly understand the exposures and the chemicals that they work with every day. Engineering controls. So often EnSafe is asked to come in and evaluate a ventilation hood or a lab hood or a welding snorkel to find out if it's performing adequately or if it's meeting minimum requirements. So we can measure the flow rate of the air going into that hood or calculate air changeovers or measure the face velocity. What that does is tells us, is it meeting a engineering or a design standard? What that does not tell us is the engineering control effective at protecting the employee? So when we install or implement an engineering control, the only way that we can evaluate whether or not that control is effective at protecting our employees is by collecting industrial hygiene sampling or data. We use those results to help determine how effective or how efficient those engineering controls are at removing those contaminants or isolating those contaminants from the employee. Emergency response to chemical release. Whenever we're responding to an emergency situation where we have a chemical release, at some point we typically would delineate response zones. So utilizing direct reading instrumentation or even potentially integrated sampling, we can use those concentrations, those results, to help determine where our hot, warm, and cold zones are. Where should we put our decontamination line? Where can we put our support personnel where additional PPE is not needed? We can also use sampling to evaluate effectiveness of decontamination and also evaluate the appropriateness of our PPE for our responders and our decontamination personnel. So industrial hygiene sampling has its place with emergency response as well. Employee concerns and complaints. Typically 50 to 70% of the times OSHA samples at a facility in response to samples at a facility is in response to an employee complaint. So an employee smells something that's off, or maybe they feel like they're having some sort of symptom from the chemical that they're working with. So they call the OSHA tip line, and next thing we know, we've got OSHA calling us to schedule a visit. So having good historical sampling data will help show OSHA that, you know, we're doing everything we can to protect our employees. The odor threshold of that chemical is XYZ, but our concentrations are this, and they are all below the established permissible exposure limits. Additionally, having data will help us from a liability standpoint. So here's a table that I pulled from the BLS data on DART cases, or days away, restricted, or transferred, related to industrial hygiene exposures. So you can see we had 16,000 or so days away, restricted, or transferred cases related to this small group of industrial hygiene related incidents. There's others, but this is just a small sample. If for some of these cases, I know we would like to believe that nobody would do anything that was unethical, but there are instances where an employee may report something and they may report a symptom or a health effect of an exposure that may not necessarily be the case. So without any data showing that we've done our due diligence in protecting our employees by evaluating those exposures, we don't have any defense against that accusation. So it's important that we have a strong industrial hygiene sampling program to make sure that we can be prepared to protect our employees and be prepared in the event somebody questions whether or not we're doing our job to protect them. And finally, industrial hygiene sampling is just the right thing to do. As an employer, our job is to protect our employees. OSHA's made advances in recent years by admitting that their exposure limits may be out of date and not protecting the worker through regulatory updates and some other things. They're making steps to get better, but there's still a lot of work to do. So in the absence of a specific exposure limit that's regulated by OSHA, there may be other resources out there that can direct us to providing sampling. At the end of the day, it's our job to protect the employees that are looking to us to keep them safe. So it's the right thing to do. So I hope from those first few slides, you got a good feel for all of the reasons why we need to collect samples. So once we've identified at our workplace the reasons or reason for collecting the samples, then we have to evaluate the potential and severity of those exposures that we know about. Those known exposures at our workplace, we need to start evaluating. So when we start this process, there's two risk assessment strategies, qualitative and quantitative. A qualitative industrial hygiene risk assessment helps us determine the potential of an exposure, while a quantitative industrial hygiene assessment helps us determine the severity of those exposures. Typically, at the beginning of this process, we start with the qualitative approach first. So the qualitative is just that. We're not collecting any numbers. We're just using other information to kind of build our case for the next step. The first step in developing that qualitative assessment is determining where your potential exposures are. If we just tried to look at every employee individually, it would end up being a much bigger project, or a bigger bite than we can take. So what we typically do is we divide all employees into similar exposure groups, or SEGs. What this does is it groups workers who conduct the same or similar work activities in the same work areas, and thereby having similar exposure potential to those hazardous substances. So Instead of looking at each individual, we say, okay, all of these guys in this department, they do very similar jobs on a day-to-day basis. We're going to group them together and look at what their specific exposures are. It's much easier to manage that group of employees than trying to look at each individual person's task and figuring out, is there something that they do differently? That we can address down the line, but from a starting point, we want to start grouping our employees into these similar exposure groups. Once we have grouped our employees into those SEGs, similar exposure groups, we need to consider how those exposures affect each employee. The foundation of any qualitative exposure assessment starts with the understanding that the understanding of the basic principle of toxicology, that the dose makes the poison. When we look at that, understanding that the key to evaluating exposures is not just that there's a chemical exposure there, or that there's a noise exposure there, or radiation exposure, but how much of that is the employee getting. So it's all about dose. So when we look at that, we understand the exposure is present and realize that we need to start thinking about not just that it's there, but how much is that employee being exposed to. We can then look at it from an acute versus chronic standpoint. Chemical exposure limits are derived from this concept. Many chemicals we may be exposed to may only have acute health effects, while others may have chronic health effects. Understanding those dose-response relationships will help us design and develop an effective industrial hygiene strategy. Luckily, we have some help with this. When different groups are developing exposure limits, they develop them with this kind of acute versus chronic mindset. So depending on what that potential health effect is, will drive what type of exposure limit we have. So time-weighted average is probably the most common. That's a full shift, 8-hour exposure. So we average this exposure, we monitor the employee, and we get an average over the full shift of what that exposure is. The next is a short-term exposure limit, usually a task-based sample. Again, it's a much shorter amount of time, but still we're averaging over that 15-minute period. Both TWA and STEL exposure limits or results that we collect are an average. So you could potentially be above that limit or below that limit. But as long as the average over your sample time is below the respective exposure limit, then we're doing a good job. The next one is a ceiling limit. Ceiling limits are a never to exceed limit. So we don't have any kind of time averaging going into this result. When we collect a sample and compare it to a ceiling limit, we're looking at a moment in time, and if at any point we exceed that limit, then we've exceeded it. There's no way to average it down from previous time during the shift. And then finally, IDLH, or immediately dangerous to life and health. The ceiling limit and the IDLH limit can sometimes be confused with each other, but the ceiling limit usually tends to indicate once we're above that concentration, we will see some kind of health effect, whereas IDLH, or immediately dangerous to life and health, those limits are more related to escape impairing health effects. So concentration so high that we couldn't self-rescue out of an area. So we couldn't get ourselves out of an area if we needed to. Groups like OSHA, NIOSH, ACGIH, and then in some states like Tennessee, TOSHA has their own limits, publish and establish different limits for us to use to make sure we're protecting our employees. So OSHA, Occupational Safety and Health Administration, they publish the PELs, or the permissible exposure limits. These are the only regulations or only limits that are regulatorily enforceable, or we have to follow them by law. The problem is, in many cases, they're outdated. They haven't been updated in some time, but these are kind of the minimum standard that we have to comply with. Another group, NIOSH, the National Institute for Occupational Safety and Health, they publish the RELs, or the recommended exposure limits. These are recommendation only, and really what these are designed to do is NIOSH develops those RELs in an effort to provide recommendation to OSHA for future updates to PELs. Sometimes, in some cases, there may be a recommended exposure limit published by NIOSH that there's not a corresponding OSHA limit. So there may be a reason that we might specifically pick a NIOSH REL in some cases. And then finally, the ACGIH, or American Conference of Governmental Industrial Hygienists. This group, although they have governmental in their name, they're not related to the federal government. They're a private group, nonprofit. They publish the TLVs, or the threshold limit values. Again, these are recommendation only, but from an industrial hygiene standpoint, this is typically thought of as the gold standard. They update and review their exposure limits every year. They're definitely the most protective from an employee health standpoint, and this is typically what we strive for achieving. If we can get below a threshold limit value, then we know that we're doing a really good job at protecting our employees' exposures. We just discussed that OSHA's limits in some cases might be outdated. So when we're selecting what group do we want to pick, just a comment that even OSHA has come out in recent years and admitted that their limits are a bit outdated. On their website, they say OSHA recognizes that many of its permissible exposure limits are outdated and inadequate for ensuring protection of worker health. Most of OSHA's PELs were issued shortly after the adoption of the Occupational Safety and Health Act of 1970 and have not been updated since that time. They recommend that employers consider using the alternative occupational exposure limits because these alternative limits may be hazardous to the workers even when the exposure levels are in compliance with relevant permissible exposure limits. So what they're saying is you could sample and be below a permissible exposure limit, the regulatory limit, but above a threshold limit value. And they're saying that because the PEL is so outdated, there may be health effects associated with exceeding that TLV, or that threshold limit value. So you really have to do a good job of understanding where your exposures are, and we have to realize that maybe the OSHA PEL is not the best solution for the exposure that we have when we're talking about comparing. So once we've determined our similar exposure groups, our occupational exposure limits, and the duration of potential exposures, we need to document all this information. So this spreadsheet on the screen is just an example. There's many ways of organizing this qualitative data, but once everything is documented, we can begin to prioritize our sampling strategy based on the risk of that exposure. When we're looking at this list of chemicals and this list of exposures, and we're trying to prioritize, consideration should be given to the health hazard of the specific chemical. So in general, if a lower limit, or a chemical that has a lower exposure limit is a higher health hazard, right? So we want to be exposed to less. So that may prioritize that particular exposure over another. The number of employees that are affected. So we may have a exposure from a health hazard standpoint that is not as extreme, but maybe it affects a widespread group of our employees. So we want to do everything we can to try to get that exposure under control. Duration of exposure is important. So that's how we help determine, are we going to collect a short-term sample or a full shift sample? And there's other considerations, but the main goal here is document all these things so you can kind of see it in front of you and start making decisions about where are we going to sample, where are we going to put our time and our money when we start collecting those samples. So once we've built that document, that qualitative assessment, now it's time to start quantitatively assessing those exposures. Remember, the quantitative assessment helps us evaluate the severity, or how bad are those exposures. We've already looked at the potential. We know where we work, we know where our chemicals are, we've noted them in our spreadsheet, we've documented all that, so we know where the potential exposures are. Now it's time to measure those things to see how bad it actually is. Usually, the next question to answer is, how many samples should we collect? So what's the most common number that we use? Well, the answer to this question is sometimes very simple and sometimes it's very complicated. But depending on the scenario, A, B, C, D, or E on the screen here, all of these could be the right answer. We could do our qualitative assessment, and based on information that we've gathered from our facility, based on objective data, maybe other research that we found, we may determine that there's no need to collect a sample because the risk is so low. On the other side, we may have a really hard time determining anything from our qualitative assessment, and we may need to start collecting samples to help build that decision logic. So there really is no one answer for how many samples we should collect. The answer really is, it depends on the exposure, it depends on the number of employees, and it depends on each individual scenario. We have to take it as a case-by-case basis. One tool that we could use in selecting the number of samples to collect is published in the NIOSH Manual of Analytical Methods. Essentially, with this table, we can find our similar exposure group size in the top row. So we've got our group of employees that are exposed similarly. Let's say there's 10 of those employees, and we find 10 in the top row. And then we look at the bottom row, and the corresponding number is 9. So according to this table, if we want to find if we want to have 90% confidence that at least one worker sampled will be in the top 10% of the exposures within the entire similar exposed group, then we would need to collect 9 samples to get that kind of statistical confidence. There's other models available with this same approach. If we want to increase our confidence to say 95%, or if we want to decrease our confidence to maybe account for collecting less samples to be a little more economical, but still have some statistical basis behind it. But this is one way to do it. Some other methods, we could sample all of the employees in the similar exposed group. So if we have a small group of employees, let's say 4 or 5 employees, it may just make sense to collect samples for all of those employees. The problem is, if that exposure group gets bigger, this can become pretty time intensive and potentially expensive, depending on the number of samples, the cost of analysis, etc. Another way to do this is look at what are our maximum risk employees, or what are our maximum risk tasks. So from our qualitative assessment, we should be able to start building that picture of where do we really see these high risk employees. So we may have a similar exposure group, but within that group, we know that, every Wednesday we do a specific batching task. Yeah, it's a routine task, but it only happens once a week. So we may concentrate our initial sampling on that high risk task, or that maximum risk task. And then our assumption is all the other tasks that group performs should be less than whatever, the exposure should be less than whatever that maximum risk task was. Oftentimes, this is the most economical option, and usually it's a good starting point. If we're kind of just getting into industrial hygiene sampling and we don't have a lot of data, or it's been a long time since we've collected some, this maximum risk approach is a good way to prioritize our time and our money. when we're trying to get our IH plan off the ground. So what does OSHA say about collecting number of samples? So the previous slide is actually pretty consistent with what OSHA says. So the employer shall identify all employees who may be exposed and accurately determine the exposure of each employee. So they say you could do it that way. You could just monitor all your employees. Then you've got one sample for every employee. They also say the employer shall develop, another option is that you can develop a representative sampling strategy and measure sufficient exposure. So we look at a similar exposure group and we figure out, okay, what are some tasks and jobs that are representative of all the things that that group does. Then we start collecting samples within each job classification for each work shift to correctly characterize and not underestimate the exposure of any employee within that group. So the goal here is if we're going to do a representative number of employees, we just want to make sure that those samples represent at least the worst case exposures. We don't want to underestimate the exposures when we're doing representative sampling. But according to OSHA and many of the chemical specific standards, this is the language. I pulled this from the formaldehyde standard, but this language or similar language is in most of those chemical specific standards. Something else to consider before we start sampling is exposure variations. So you may, we have to consider that there could be variations of concentrations of certain chemicals across the sampling period. So let's take a full shift sample, for example. If an employee has a potential exposure to toluene throughout the shift, their exposure may be higher during a certain batching task. So they have a task where they're manually or they're in close proximity to a filling process where we're loading toluene into a vat or a tank. We could potentially collect multiple samples from that same employee throughout the shift to evaluate those specific tasks or specific exposures to see, have we exceeded any kind of short-term limit? So in the example of toluene, there are published limits that are time-weighted average, which we want to collect a full sample to compare to that, but they also have peak limits or ceiling limits that we could compare to make sure that we're not exceeding any of those short-term limits. And then at the end of the day, if we have multiple samples, we can combine those results and calculate a cumulative TWA result and compare that to the full shift TWA exposure limit. So we want to make sure that we're flexible and we're sampling to fit the task and not trying to get the task to fit our sampling. We want to make sure that when we are collecting a sample, it's always representative of the normal jobs that people do, or at least the job that we're trying to characterize. Once we've determined our similar exposure groups, the number of samples, the sampling strategy, it's finally time to collect some samples. Depending on the physical state, the duration of the physical state of the chemical or the contaminant, the duration of the sample that we want to collect or need to collect, the specific question that we're trying to answer, sampling media and methods are going to differ. We may use active sampling over passive sampling for a short-term sample, or we may use direct reading instruments to evaluate one of those ceiling limits so we can see concentration over time. So depending on what that question is and the application of the sampling method, we're going to pick a different way or a different method for assessing that exposure. This can seem daunting and intimidating, but there's a lot of resources out there. NIOSH and OSHA sampling methods are kind of the gold standard when it comes to evaluating occupational exposures. These are essentially instructions or recipes for how do I evaluate an exposure to this chemical. So for numerous chemicals, we can find a specific method, and it will detail the sampling media that we have to use. It will detail how long the minimum sample time, the maximum sample time, How do we ship it to the laboratory? All of those things are included in those sampling methods, in that documentation. In addition, there's industry experts. You know, if you're at a facility and you've got corporate representation that you know are experts in industrial hygiene, or at least they have a lot of experience, reach out to them. A great resource is one of your IH laboratories. So whatever lab you're getting the sampling media from, they usually have a lot of knowledge about the specifics of how that sample is collected, the specifics of what are the limitations of that. So it's important that, yeah, we do it right, but we understand that there's resources out there for us to get and use to make sure that we're doing it the right way. So finally, we've collected our samples. The results have been emailed to us from the lab, and everything's below our reference exposure limit. Well, unfortunately, that's not always the case. Sometimes we get bad news, right? Sometimes a result comes back and it's higher than we expected, or maybe we did expect it, but still not the news that we wanted. So when we have a high result that's either above an exposure limit or higher than we're comfortable with, we have to do something to control that exposure. So we'll pull up the old hierarchy of controls, which I'm sure everybody, I hope everybody on this call is likely seen before, but it's an important one, right? The idea here is these are listed, these are the types of controls listed by how effective they can be, right? Elimination, if we can eliminate the hazard altogether, then our job is done. If we can substitute it with something that's less hazardous, that's great too. Most of the time, our work really begins at that yellow section, right? Where we're starting to talk about engineering controls, administrative controls, and PPE. So not to harp too much on this hierarchy of control slide, but you know, the take home here is that we have to evaluate alternative options to PPE. We can't just throw people in respirators and say, you know, our job is done. We have to evaluate, are there alternative means for protecting our employees beyond personal protective equipment? And actually, this is required by OSHA. OSHA says we have to evaluate these. So OSHA says in all cases, administrative or engineering controls must first be determined and implemented whenever feasible. So if they can be implemented, then we have to. If the controls are not feasible, PPE or other control methods or protective means shall be used to keep the exposure of employees to air contaminants within the limits, so below the permissible exposure limits. So that's what it says in that 1910-1000 section. So that would apply to all of those chemicals where we just have a specific exposure limit and no additional requirements. If we dig into some of those chemical specific standards, the next paragraph here applies to those. So this language was pulled from the silica standard, but similar language is in the formaldehyde standard or the lead standard or many of the other ones. So it says, the employer shall use engineering and work practice controls to reduce and maintain employee exposure to below the PEL, unless the employer can demonstrate that such controls are not feasible. If those controls are not feasible or not sufficient to reduce employee exposure to or below the PEL, the employer should still use them to reduce the exposure to the lowest feasible level. So the difference here, the first paragraph says, in some cases, if engineering controls are not feasible, it's okay to default to PPE. But for chemical specific standards, many times OSHA says, even though our engineering controls aren't bringing us to a level that's below the exposure limit, we still have to use them to lower them as much as possible and then supplement with PPE, respiratory protection, et cetera. So when we look back at this hierarchy of controls, this isn't just a philosophical thing that we have to say, okay, we'll try to do it. OSHA is requiring us to do this. Um, so when we have a high exposure, it can be difficult to work through the process of trying to figure out and document the thought process behind establishing those control measures, establishing ventilation. So something that we're providing today at the end of the presentation is our exposure control plan tool. This will be in a fillable PDF, but it will allow you to document information about the contaminant that was sampled, what were the results, what's the corresponding exposure limit, where did we collect the sample, description of the job and the specific exposure, and then it allows us to document our thought process and our attempts at applying controls other than PPE, or at least controls before we rely on PPE. So we'll provide this at the end of the session today. This is just a tool that can help through that that assessment or that process. So then finally, we've worked really hard up to this point. We've gone through and identified why do we need to sample. We've evaluated our exposures through a qualitative assessment and then put that in action and created a quantitative assessment where we evaluated the severity of those exposures. Then we put controls in place. We documented our efforts in implementing those controls. But then it doesn't stop there. We have to reevaluate the effectiveness of those controls. Back to one of the first slides, right? When we put those controls in place, we should be collecting samples on the back end of that to make sure that we're getting effective controls or effective reduction in those exposures. Then we modify our plan based on those new results. So you can't have a safety presentation without a flow chart. So here's our obligatory flow chart, right? So first we do our basic characterization, which is that identify the exposure, identify the need of our exposure assessments. Then we do our qualitative and quantitative assessment. One of three things is going to happen. We're going to get an acceptable result where either we've determined that the risk is low enough that we don't need to collect a sample, or we collect a sample and the results are below whatever limit that we're comparing to. So then we kick it back down and we periodically reassess. So that may be next year, that may be 3 years from now, or we may just wait until maybe the process changes or the chemical batch changes and our exposure characterization is a little bit different. The next thing that could happen is uncertain. We may collect 2 samples and one sample is really high and one sample is low. Well, that means we probably need to gather more information, figure out what was the difference between the 2 employees that were sampled, what was different on that day of sampling. And ultimately, we're probably going to collect more samples. And then finally, unacceptable, where we have a result that is over a limit or a result that we're not comfortable with. Then we would implement a control, and then again, we kick it back up to the start. So this whole thing, an IH plan or an IH program is a cycle, and it's not a straight line. So we never really get to an end point. We're just continually updating that qualitative assessment, changing our risks and our priorities, and then planning for future sampling so that we can continually evaluate our employees' exposures. When we talk about having an IH program and incorporating all these things into a kind of living and breathing written program that we're using to make decisions and protect employees, it's good to verify that that program is doing what it needs to do. So the second tool that we're going to be providing you at the end of the session today is a program performance verification. So this is a 3-page document, I believe, but what it does is it asks specific questions about things that should be in your industrial hygiene program. And if you're honest with yourself, by the end of it, you're going to get a good scorecard for your industrial hygiene program at your facility or at your company. And you can utilize this to help make improvements, utilize the exposure control plan to document the efforts that you're making so that we can do we can do what our job is, and that's protecting our workers, protecting our coworkers. Of course, you can always reach out to EnSafe or reach out to your other resources, IH laboratories, corporate health and safety, regional health and safety. Don't feel like you're in this alone. There's always resources out there. There's people that that can help. And we hope that you would take advantage of those resources when you need it. With that being said, that's the end of the presentation. So I'll kick it back to Leo to see if we have any questions.
Thanks, Joe. Great job. We do have a few questions. We've had a number of questions. I've answered those live some of them live during the presentation, but we do have some others here that I'll read to you. So first one, Joe, what should you do as an IH if you find that your sampling equipment faults in the field?
Yeah, so that happens. Anybody that's collected industrial hygiene sampling, we know that either a battery will fault or we'll just die, or we lose something, or the employee comes back and says the tube got disconnected. So I think it really just depends on how much information you can get. I think ultimately we have to flag that result and question how representative it might be. But depending on how much sample time we have and how much information we know about the time that of the sample that was collected, we may still send that sample in for analysis, just because good data and bad data is still data, and we may be able to use that result to make a decision in the future. But you definitely want to note when something happens, something faults. Ultimately, something may happen early enough in the day, or we can't recoup enough information, and we may just void that sample altogether and not submit it for analysis.
Okay, great. Thank you. Next question. I typically reach out to the lab director to determine if samples can be combined. That is collecting, I assume he's meaning collecting multiple air contaminants on one sampling device. So what are the downsides of doing that?
Yeah, so a lot of times the thing that you have to be careful with is there's numerous chemicals that can be combined and collected on the same media at the same time. But sometimes where we're limited is on the analysis side. So a chemical can be grouped with other chemicals on the same media, same method, but when we send it in for analysis, there's issues on the analysis side where the lab may say, well, we can't analyze for methanol because we can't combine the analysis of methanol and some other chemical in the same with the same sample. So we do that very often, and even though there's a lot of chemicals I know can be combined, almost every time I shoot an email to the lab just to verify, hey, can these be collected and analyzed at the same time? Something else to consider when we're combining, usually if you're able to combine analytes, especially if they're organic vapors, for example, something to consider is the mixture calculation. So make sure that the combined mixture of those chemicals isn't causing some kind of additive health effect to where we may want to assess those chemicals as a combined mixture versus individual components. And there's information on there. I think it's called the mixture calculation, but it's relatively easy. But that's something else to consider. That I don't know if that's a downside, but it's something to consider.
Great, thanks. Thank you. There have been some discussions about the use of Bayesian statistics to develop sampling strategies. And I commented that it is a model, a technique, a method that can be used to help develop sampling strategies. It is a rather complex topic, and it's not something that we really could get into significant detail here in a 1-hour webinar and covering everything else. But it is a tool that is available. I would say you seriously need some training on that topic before you try to employ it and use it for developing sampling strategies. And also, we had a colleague here mention that the American Industrial Hygiene Association has published a number of documents on exposure assessment strategies which do address Bayesian statistics and the similar exposure group. So AIHA has a number of good references out there regarding sampling strategies. Next question, where did you say you could find the sample methods out there? So presumably that's the NIOSH analytical methods?
Yes. The NIOSH Manual of Analytical Methods is one. So if you go to NIOSH's website, and in the search bar on their website, or even in Google or some other search engine, search NIOSH Manual of Analytical Methods. It'll pull up a library. You can select by CAS number. You can select alphabetically by chemical. In addition to NIOSH methods, OSHA also has methods published on their website for different chemicals and sampling methods. And then again, I keep going back to, really utilizing the lab that you're going to send your samples to. Sometimes we may find a method that a lab may say, well, we can't analyze using that method, but we can use this other validated method. Is that okay? So they're very knowledgeable in the NIOSH and OSHA methods, and reaching out to them if you're having trouble finding, or reaching out to other resources if you're having trouble finding a specific method. But as a starting place, I always start with NIOSH and OSHA methods, which can be found on their websites.
Okay. Next question is, what is the minimum amount of time needed for full shift time-weighted average sampling? For example, is it a percentage of the shift, or would it be a number of hours? Any thoughts on that, Joe?
Yeah, so I get there is an answer to this, but I always go back to the response I had on the previous question was, even bad data is still data. So let's say we planned on sampling for the full shift, but we only were able to get 4 hours. Well, that's not ideal, but that 4 hours may tell us something important. If we're looking at, if we want to look for a reference, we can go to, it's either the OSHA technical manual or the field operations manual, which says what an OSHA inspector should do, and that would be the shift length minus 1 hour. So if it's an 8-hour shift, the OSHA inspector is going to try to get at least 7 hours. They're going to try to get more than that, but they're going to sample for at least 7 hours. So a good rule of thumb is to shoot for, shift length minus an hour. And that's relatively accurate on how we approach things too, because a lot of times we'll arrive at a site and there's a little bit of time at the front end where the employees have to have their meeting and do what they got to do, and then we want to get the sampling equipment off of them before the end of the shift so that they can get out of there to go home. So if it's an 8-hour shift, really difficult to collect 480 minutes or 8 hours of a sample. So the goal should be collect as much as you can, but with anything, you have to be realistic and be able to work with the people that you're sampling.
Thank you. Next question. If OSHA has a limit for a material measured as total particulate, but ACGIH has a more conservative TLV for the same material for a particulate size, that is, say, thoracic, a thoracic TLV, would you do both total and thoracic sampling or just thoracic?
This is a good question that we we ask ourselves all the time. I think if we had an absence of no monitoring data, so let's say we don't have any historical data that we can compare to the regulatory limit, which is a total fraction, I would say that you at least want to get some data points that measure directly to the total so that we can say a direct comparison sample to the regulatory limit, we are below it. Moving forward, I think a good approach is using the thoracic TLV and collecting a thoracic sample, because now we've established we're meeting regulatory requirements, and now we're moving to, are we doing everything we can to protect the employee by collecting a thoracic sample? That's the approach that I would use. Of course, you know, if the guy you're sampling is a nice guy, he may volunteer and say, you can collect 2 samples on me at one time, which is a way to do it as well. You just want to be careful that that's not, you know, not getting in the way of him doing his job. But we've also done that as well. And we see this problem often with, you know, now the ACGH is gone away from total fraction for almost all of their metals. They're either respirable or inhalable. But all of OSHA's metal limits for, let's say, welding fume exposure are our total limits. So that's even more complicated because it's not just one compound. It's, you know, 13 or so compounds with some respirable, some inhalable, and then OSHA has the total. So it does get difficult.
And I'll add one comment. It's possible that if you were to collect a total sample and a thoracic sample or a respirable sample or an inhalable sample, that you may be below the exposure limit for one of them, but you may exceed it for the other. And you can't assume that if you're below the total exposure limit, that you'll automatically be below the thoracic limit or the respirable limit if one exists there.
Right.
So those are independent of each other.
Correct.
Next question, how do you recommend handling chemicals without any OELs from OSHA, ACGIH, and or NIOSH? So if there are no exposure limits.
Sure. So there's a couple other resources to check before we kind of throw that out the window. You can check with the manufacturer of the chemical. Sometimes a chemical manufacturer may have established its own internal limit. You can check outside of the United States. So the German MAC limits. Sometimes there's a limit, an oddball limit that they have that is not listed by one of the other, you know, U.S.-based agencies. You can look at the chemical. You can look at the chemical, and if it's similar in chemical composition to something else, we could utilize a surrogate exposure limit. Those are just a couple ideas off the top of my head. Leo?
Yeah, and those are all good. And I'll add one other concept you can use is what's called the occupational exposure banding, which is you assign a chemical to a particular exposure band based on some data that you know about the chemical. So there are a number of techniques that you can use out there. All right, and we have one last question, and then we'll close it here. Any way to discard results that are outliers if tampering is suspected? And I'll take a stab at that one, Joe, if you don't mind. Yeah, if you suspect that an employee may have tampered with the sample, the way I typically handle that is I have a conversation with my contact at the site, usually the health and safety manager, and if we suspect tampering, we'll typically try to resample that SEG again or that employee, or if there's another employee doing that same task, maybe sample that employee and get additional data to see if in fact tampering may be possible. But I wouldn't automatically discard a result. Don't always assume that if it's an outlier that it is automatically associated with malicious tampering.
Yeah, you know, some methods that I've seen employed to combat that, you know, especially if the tampering results in a high result, telling an employee now that they have to wear a respirator because of that high result usually prevents it from happening again. So then when you collect the resample, I think they're much less likely to tamper with that result and just let it sit on their shoulder and do its thing.
Okay, well, I think it's 12:30 Central Time. We're going to wrap this up today. Thank you very much for joining us today. Everybody that registered for this will get a certificate of attendance. We'll email those out to you in the next day or two. I'm going to send an email here in just a few minutes with a link to a SurveyMonkey survey. It's just a short 4-question survey. Would appreciate your feedback on this webinar. And we've got, like I said earlier, this is our third in a series of 8. Our next webinar is a week from today, and I suspect we'll see many of you at that webinar as well. So thank you again for attending, and we'll end the session now.